if we kind of bum rush, we're going to knock out 2, 3, and 2, 4 today, which won't have any problems at all getting through both those. It kind of all melts together anyway. One of the things that I have learned over the course of a few years, I think we've had the honors class for about 6 or 7 years now. And one of the things that I've learned that I should never skip over this section, because there's a method that we do stuff in terms of graphing to help us visualize stuff that is so unbelievably quick to work with, that most students never knew about. So what I want to do is just kind of go back a little bit to the idea of how do you write equations of lines, what are the different equations of lines, and what do they stand for and stuff. Okay? For example, what's slope-intercept? Perfect. Slope-intercept form is y equals mx plus b, where m is your slope and b is your what? Y-intercept. Good. When we did this, the reason that we taught slope-intercept form is because it's a very easy way to graph. If you had your equation written in the slope-intercept form, you knew where to start your graph on the y-axis, your intercept, and then you also knew your slope, where to walk up and over or down and over from that spot. So you had a really good starting point. What was weird about slope-intercept form is that a lot of times your equations that you were given weren't originally written within that realm. They were usually written in what was called standard form. Standard form was that ax plus by equals c. Does that vaguely ring a bell? When you see it, you'll remember it. Okay. Now, when you had standard form, there were a couple of rules that they threw at you. They said that, bless you, they said that A, B, and C had to have a GCF of 1, which means you just factor out the greatest common factor. A and B both couldn't be equal to 0 because then you would no longer cease to have a line. And which other one? I'm sure there was something else I'm forgetting. But the idea here was when you had standard form, you had something like this. I can write this out. You had 2x plus 3y equals 12. And traditionally, we would say, rewrite that into slope-intercept form. What you would do then is you would solve that equation for what variable? Y. What you're doing then is you're solving what's called a literal equation. What that means is you're trying to isolate one part of it and move everything else out. And that's something you guys have done over and over and over and over again. You've done literal equations where you've had distance equals rate times time. Solve for time, what do you do? Divide by rate. So distance divided by rate equals time. You'll see this idea a lot. I think chemistry does it a lot, where they isolate variables within equations. It's a very common thing. If you guys get to the point, I don't know, are you guys taking physics this year? That's right, you were saying that, Jen. I know that there are some math things that you're going to run into. I think you were telling me that earlier. There are a few terms, a couple of things, whether it's chemistry or physics you might get to that you might not know what that means yet. Please stop in for flex, ask me a question before school or anything like that. I'll be more than happy to show you. I know it does come up in chemistry, probably before that, something that we'll teach you guys, things called logarithms. If that happens, just let me know. I'll show you what they do, how you work with them, how you solve them, how you use the calculator to do it. It's super easy. It's nothing too crazy. It just sounds really, really weird when you're talking about chemistry stuff. And the reason I know that is, like I said, my wife used to teach AP Chem. She came home one time and she goes, "What the hell do they have logarithms?" And I'm like, "Well," and I started to explain to her. She's like, "Shut up," because she didn't want to learn. So, conversations at our house are awesome about that stuff. Our poor kids. Anyway, so what would you do first to get y by itself for this one? Okay, so you get 3y equals negative 2x plus 12, and then what? Divide by 3. Good. don't forget to divide everything by 3. A lot of times people forget that last part. If you did this before, that was probably the one thing you guys messed up. So you get a slope-intercept form of y equals negative 2/3 x plus 4. And then you would go on your merry way and plot it at 4 and walk your slope of negative 2/3. We agree with me on that? So obviously, there's a time and a place to use graph paper. Bless you. And if I ever need you guys to actually use graph paper, I'll give you graph paper. I've got some really nice, I've made pages of just this grid, and it's a really clean grid. I don't want you to use this today, but I want to show you why what I'm going to show you here is going to work. The line we just said was what? Negative 2/3 was y equals negative 2/3 x plus 4. Okay, so that means I would start it at 4, down to right 3, down to right 3, up to left 3, and so on and so on. We would get that line. You guys okay with that? Okay. Now, go back to the idea of a minute ago. We had the equation of, what was it? 2x plus 3y equaled 12. That's where we started, correct? All right. When you have x, y coordinate systems, just your standard two-dimensional plane. When you cross the y-axis, the vertical axis, what's your value of x? When you cross, correct, when you cross the y-axis, the value for x is 0. Therefore, when you cross the x-axis, what's your value for y? 0. So when you have something that's written into standard form, you can do what are called quick graphs. What I mean by that is, if I take my value of x per 0, I'm looking for my y-intercept. What's my y-intercept? 4. I solve for y. If I cover up the y value, it means it's 0. What's my x-intercept? See how quick that is? Here's your 2. Here's your 4. I'm sorry, here's your 4. Here's your 6. How many points do you need to make a line? 2 of them. You need 2 of them. And you get your line. Can I look at that and figure out my slope? I went down 4, right 6. Negative 4 over 6, which is negative 2/3. Look at the 2 and the 3 in your standard form. Your 2 and the 3 were your A and the B, weren't they? If you take that information a step further, isn't your slope going to be the opposite of A over B? It will always work. Standard form is awesome because you don't have to math. You don't. You don't have to go through and distribute and simplify and work through everything. Standard form is going to be your absolute best friend because next week, how many we get to it this week? Next week, we're going to do stuff like this, where we'll have 4x minus 3y is less than or equal to 24. And I'm going to graph that along with 2x plus 6y. Oh, I don't want to use the 6. 2x plus 5y is greater than 10. And I'm going to look for the shaded region of those two problems without mathing it, without getting y by itself, without walking through points and slopes and slope-intercept forms and all that. I'm going to cover and solve and quick graph it. That's the idea that I want you guys to see, because I've learned you guys never saw that before. Or if you did, you're like, maybe? Okay. Now, does that somewhat look familiar, or you're just going, wow, you just blew my mind, Dad. This is so much easier than I ever thought. This is why I want to show you guys this, because you never saw that. Remember, it's cover and solve. Does it change, just for real quick, let's say it was 2x minus 3y equals 12. What's your y-intercept now? -4. You just got to watch that if one of them is negative. You just got to be careful with it. That's the only thing you have to worry about. Cover and solve. You're substituting in 0 for x to get your y-intercept. You substitute in 0 for y to get your x-intercept. It's the idea of how intercepts work. It just makes math easier. All right? Look, something new. It's only like the third day. Yay. You now know how to graph. Horizontal and vertical lines. What does a horizontal line look like? Don't say straight. Sideways. What is this sideways? Perpendicular to what? Good. I'll give you that. What are you saying? So horizontal lines, I know you meant by sideways. Horizontal lines go left to right. We talked about this yesterday. What's the slope of every horizontal line? 0, because there's an O in the word horizontal. Shut up, you know it makes sense. Okay. When you have a horizontal line, what value in the graph never changes? If you're moving left to right on the graph, you never change, you have a 0 slope. The y value never changes. The y value stays constant. The equation of every single horizontal line will always be y equals some number, no matter what. If you have a horizontal line, it will always be y equals a number. No variables, no nothing, just y equals 2. Y equals -6. Y equals 413. On the other hand, then, vertical lines. Vertical lines, up and down. What's the slope of every single vertical line? It's undefined. Slopes are always undefined for vertical lines. What never changes on a vertical line? The x value. So your x value stays constant. So every single vertical line is always x equals some number. Okay. What's parallel to horizontal? Horizontal. What's parallel to vertical? What's perpendicular to vertical? And what's perpendicular to horizontal? Vertical. Now, this is where it gets a little bit weird. Y equals a number is always parallel to y equals a number. You guys remember the symbol for that, for parallel with 2 slashes? Okay. You can do the same thing with vertical. X equals a number is always parallel to x equals a number, which therefore means they have to be perpendicular to one another. The reason why I'm writing that out is because that's one of the things that we talk about in this section here about how do you write equations of lines that are parallel or perpendicular to one another. And remembering that y equals a number is perpendicular to x equals a number is a little subtle shortcut that will show up from time to time. Now, we did talk about 2 ways of writing equations of lines. We did slope-intercept. It's standard form. What's the third way? What's that? Point-slope form. Now, point-slope form, if you recall, is kind of like the working method to writing equations of lines. It's generally what you use to get slope-intercept. It's what you, when you have 2 points. When you have 2 points, you can define its slope. When you have its slope, you can use one of the points to figure out the intercepts, and so on and so on. So the working version that we like to use a lot is what's called point-slope form. Obviously, your slope is the m. and your ordered pair, your point, is defined at x sub 1, y sub 1. You're going to be given it. Or you're given 2 points. When you had point slope form, what you'd wind up doing all the time is that you would substitute in the values, and what would you get by itself then? Do you remember? Y, very good. Man, you're smart today. Nice work. Not to say you weren't yesterday, or you won't be tomorrow. Point slope form was the working method to get to slope intercept. It's a super common way. That's what you guys have all been using forever. It's something that I've been telling students. It's the most useful linear equation that you'll get. For example, you can do stuff like this. Scroll through it. I want you guys to take a minute, write the equation of the line for these two problems. Obviously, you'll probably start with point slope form, but write it into slope intercept form when you're done. Take a couple minutes and give it a shot, and we'll check it. Let's see. To start this one, I got point slope form. If you forgot what point slope form was, and if you haven't used it in a while, just write it down a couple of times as you do the problems. Call me crazy, but the more you write down stuff when you're using it, the better you're actually gonna, remember it. Inconceivable. Stay off the light, King, would you? Okay, sorry. Y minus 2, negative 3, x minus 5. So far, so good? Distribute, we get negative 3x plus 15. Add 2, you get y. Sorry, my handwriting's getting bad. Negative 3x and a 17. Now, if you were wrong, and you're not sure if you did it correctly, couldn't you just take that x and y value of 5 and 2 and see if it's equal? What's negative 3 times 5? Negative 15. What's negative 15 and 17? 2. Negative 15 and 17. Or, sorry, plus 17. Excuse me. You haven't quite understood my vernacular yet. Do you understand the words coming out of my mouth? Never a dull moment, I tell you. Other one, get your slope first. 2 minus 8, 1 minus 4, negative 6, negative 3, slope of 2. Does it matter which ordered pair you choose to then go with slope, point slope, excuse me? No, makes no difference. If you do it correct, you should get the same answer. If you don't, you're goofed. Y minus 8 is 2 times x minus 4. 2x minus 8, add 8, we get y is 2x. Okay? What's 2 times 4? 8. Okay, what's 2 times 1? 2. Okay. Yes, sir. It is. You have to look closely. Or if you want to zero it in, we have to squint. And it's all just good, clean fun. But does the fun never end? You're rolling your eyes so bad, you're like, That was hardcore roll your eyes. Thanks. That was great. That was perfect. All right. Last little one here. Come on, some knew how to use this smart board, right? Just so you guys know, the math department are really the only ones that still really use the smart board. Um, we were the first ones to get it in the entire school district back in. Um, we were at the old building still. I want to say it's probably been at least, yeah, it's been at least 10 years. At the very least 10 years. It's probably more than that. It's probably been, no, you're probably right, about 10 years, I'd say. It's about it. When we first got the smart boards, the math department were the guinea pigs, and we went through all these different trainings and all these different sessions, and we learned all this how to integrate, how to go through all this stuff, and now I find it to just be such an integral part of what I can do every day, whether it's just doing something stupid to make you guys laugh, to break up the monotony of it, because math is dry. I get it. Air 5 for that. Yeah. Oh, are you kidding me? You're not lying that it's like the worst day ever. But if you could have seen her eyes roll, guys, it was just imagine the perfect. Oh. With the sigh, it was great. Anyway, so this is also something you guys have done. Write the equation of the lines that are parallel, or write the equation of the lines that are perpendicular to a given line through a specific point. I know you've all seen this before. When I've done these problems, whether I've taught this in the Honors Algebra 2 class, we do this in geometry, or if I've taught Algebra A, or Algebra B, or Algebra 1, the lower level algebra classes, I always do the exact same thing. Because whether it's the top going way too fast, which you guys do, or the bottom not knowing how to do their steps correctly, if you follow this simplistic way of setting these problems up, you'll be hard pressed to screw it up. You guys are the ones that will go through things too fast and make a dumb mistake. Not that you didn't know how to math, but you just make a simple mistake. The guys that struggle with this have a hard time understanding what to do first because it's hard to conceptualize what you're trying to do. So by doing it this way, it kind of encompasses everybody. So what I always do is this. The first thing I always do for the problem is I identify what is my original slope. In this problem, it says write the equation of the line that passes through 1, -6, that's perpendicular to the line, y equals 3x plus 7. What's the original slope of the line I'm working with? 3. Okay. So I'm writing it down. My original slope is 3. Second step, I would say, well, is it a parallel slope I'm trying to find, or is it a perpendicular slope I'm trying to find? What does the problem tell me to do? Perpendicular. So I'm not going to look at this. What's perpendicular to a slope of 3? Reciprocal, -1/3. Very good. Okay. So my perpendicular slope is -1/3. Third step would be to use point slope form and solve for y. The reason that I put in that second step is because of this, because of you guys. You guys will just go through so fast and you will say, oh, my last problem I do is parallel means this problem is parallel, always means the next problem is parallel, and all of a sudden you just did all these parallels. You're like, did I do perpendicular? And you'll forget. By putting in that second step, it forces you to reread the question. Is it a parallel or is it a perpendicular problem? It slows you down for 5 seconds. That's all it does. For the other guys, it's, okay, makes me rethink, okay, parallel, same, perpendicular, opposite reciprocals. See where I'm going with that? It brings in everybody, whether you can pick up on this stuff super fast versus, okay, I need a little more structure to go through it. Now, point slope form is easy. Y plus 6. Is it okay if I write y plus 6 right away? We're going to have a lot of this stuff, of opposite stuff we'll write out. -1/3 x, what was it, -1. And now I just go ahead and distribute and solve for y. Again, not too crazy. Now the weird part. I have to subtract 6 over to the 1/3. When you subtract fractions, what do you have to have? Common denominator, very good. I don't know about you, but I don't want to think that hard. So do you remember how to use the fraction bar on your calculator? Fraction bar on the calculator. Quick reminder. When you use the fraction bar, you don't, I mean, if you can do common denominator here, that's fine. Remember 6, 18 over 3. It's not that bad. If you get really crappy ones, there's no reason. The most common thing you'll probably use on this calculator is to create a fraction bar. Alpha, y equals. Enter. Bless you. Make your fraction bar. 1/3. Hit the right arrow, subtract 6. 1/3 minus 6. And once you input it with a fraction, it'll export it as a fraction. If you input it with a decimal, it'll export it with a decimal. This will also become really handy when we use our tables in the y equals stuff. If you use 1/2, you'll get fractions for your y's. If you use 0.5, you'll get decimals. Just a little, and this comes up, it's not always, but you'll start to see that. Which means your final equation would have been, what, 1/3? And you're done. Okay. Not terrible. Horrible. Well, you'll get over it. I posted the problems I want you guys to work on this evening online already. They're on the calendar. There's only a handful of them. You should be able to knock those out really quick. They're not that bad. Tomorrow we will talk about something else with. Oh yeah, tomorrow we'll start talking about graphing inequalities. We're going to be using that quick graph stuff all the time. Then on Thursday we'll talk about, I think it's absolute value on Thursday. Okay, we graph those, and then Friday. I forget what we do. All right, it's posted there.